All right, ladies and gentlemen, now we're going to practice probability, and we're also going to examine what a complement is, or what the term complement means as far as probability is concerned. So here we have a box of random letters, and if a letter is selected from the box at random, what is the probability of choosing a B? We would write that by putting P of B, in which B is the number of the favorable event. So we put the number of favorable outcomes, which if we count the letters B over here, we can see there are 3. And if we count all of the total possible outcomes, we have a total of 12. So we would write this as 3 out of 12. When we simplify it, we end up with 1/4, and this can be converted then into a decimal, and oftentimes we will give probability as a percentage. So the decimal form of 1/4 is 25 hundredths, and as a percent, 25%. See if you can do the probability of a consonant. Again, think of the favorable outcomes over total outcomes. You should have come up with 8/12, and then simplified to 2/3. And as a decimal, we get 0.6 repeating. Now, when we convert that to a percent, we have to remember that the 6 is repeating, so it's not 60%, it's 66%. And if we're rounding to the nearest percentage, it's 66.6. which tells us we need to round up, and that's where we get 67%. Now, what if I asked you to find the probability of not being a consonant? Or we could say the probability of a vowel. This is what we call the complement of an event. It's the number of outcomes that are not contained within the event itself. So everything that's not a consonant would be a vowel. So we could either say the probability of not a consonant, or we could say the probability of a vowel is the complement of the probability of a consonant. Anytime that you have a complement, you can add the number or the probability of the event plus the probability of that event not occurring, and you should get a probability of 1, which means 100% of the time it's either going to be that event or it's not going to be that event. And that's what a complement is. Let's try some. Find the probability of a consonant. We just did this one, and we said you get 8/12, which simplifies to 2/3, and eventually you get 67%. Well, what is the probability of getting a vowel or not a consonant? It would be the complement to this. And we could say there are 4 favorable outcomes out of 12 total outcomes, which simplifies to 1/3. The decimal form is 0.3 repeating, which is equal to 33%. Now, going back to what we had said on the last one, the probability of a consonant plus the probability of a vowel, which is the complement, should equal 1. So if we look at this and we have 8 out of 12 as the probability of a consonant, when we add the probability of a vowel, which is the complement, together we get 12/12, which is equal to 1, which means that 100% of the time you're going to either get a consonant or a vowel. And that's what a complement is. It's basically the opposite, or the other amount. Now, you may have noticed that 67% plus 33% actually equals 100%. So that's another way you can find the complement. If you know that the consonant is 67%, we could take 100% over here and subtract 67 to get the complement, 33%. Let's try a couple more. This time we have two different events taking place. If a letter is selected at random from the box and a number cube is rolled, a six-sided number cube, what is the probability of choosing a vowel and rolling an even number? You should have this set up just like we see down here, the probability of a vowel and an even number. On this type of an event, we want to put the probability of the first event and then multiply that times the probability of the second event. And that should give us the probability of the first event and the second event occurring. So the number of favorable outcomes for a vowel we already said was 4 out of 12. Well, on the number cube, the probability of getting an even would be 3 out of 6. So we're going to multiply these two numbers. Now, just like we had learned before, we want to cross cancel if possible. And here the 4 and the 12, we can actually simplify that, and we end up with 1/3. And then again, we can cross cancel the two 3's, where we end up with 1. And whenever we multiply those numbers, then we get 1/6. Try writing this now as a fraction as a decimal and a percent. Try to find the probability of the letter D in 3. Go ahead and do it on your own. Okay, let's see what you got. The probability of D is 3 favorable outcomes out of 12 total outcomes. The probability of the second event, getting a 3 on the number cube, is 1 out of 6. And when we multiply them together, once again, cross cancel if possible. And I'm going to cross cancel the 3 and the 6 this time. The 6 becomes a 2 and the 3 becomes a 1. And now we can multiply the numerators and the denominators to get 1/24. Again, try to write as a decimal and as a percent. Let's try the next one. The probability of F and 1. So we go back up to our box. The probability or likelihood of selecting an F would be 2 out of 12. And rolling a 1 would be 1 out of 6. So we're going to come down here, and we have 2/12 and 1/6. And when you cross cancel that and multiply the numerators and denominators, we end up with 1/36. Again, write this as a decimal and as a percent. Now, we're going to take a look at using the counting principle. An ice cream shop offers chocolate dipped cone, waffle cone, and original cone. You can get vanilla, chocolate, or strawberry ice cream, and you also get choice of either no toppings, sprinkles, chocolate syrup, or caramel. How many different combinations can you make if you are only allowed one flavor of ice cream and one topping? Obviously, only one type of cone as well. Well, we can use the counting principle by counting the number of possibilities. And first, looking at the cones, we have 3 possible cones. And then we also have 3 possible flavors of ice cream and 4 toppings. And when we multiply them, it gives us the number of possible outcomes. And in this case, 3 times 3 is 9, times 4 is 36. Why would we have the counting principle instead of a tree diagram? Well, drawing a tree diagram with 36 different items would be pretty complex. But imagine this next problem. If you could build your own lunch and you could pick one entree, a dessert, a vegetable, a choice of beverage, and a fruit, and then they offer you 3 possible entrees like pizza, taco, or spaghetti. And they offer you 3 types of vegetables: carrots, broccoli, cauliflower. 4 types of milk: chocolate, strawberry, whole, low fat. And then you also have either applesauce or peaches for a fruit, and the choice of a cookie or cake for the dessert. Well, how many different possibilities could you make for that one? Again, you can already see the tree diagram would take a very long time. Go ahead and solve this one on your own. And I hope this helped you out with better understanding the counting principle and finding probability for a single event as well as 2 events. See ya.